Now our next speaker is Stanislav Komanec. Is it right? Komanec. Upgrading PostgreSQL on AWS RDS with almost now zero downtime. I'll put on slides.
Thank you. Okay, guys, I had a feeling that we are a little bit sleepy here, so I would love to ask you for one viewer, please, turn back to the left and say hello to your neighbor. Can you do that?
Like this girl, turn to your left and say hello.
Okay. Great.
Be gentle.
Thank you. Yes. So hi, I'm Stano Komanec, and tonight I would like to tell you something about how we upgrade and how we should upgrade PostgreSQL and AWS RDS. I know it doesn't seem too much connected to Python, right? But I will get to that, I promise. Right. So first thing first, let me a little bit introduce myself, and I don't know why my clicker's not working. Great. I'm currently working as a head of platform. I used to be a Python developer. Then I became team leader of booking backend team, which is currently Stanley's team. What does it mean to platform team at Kiwi.com? Our mission or our main goal is to help developer to making better software faster. Sounds really high and promising, but how do we do that? We are providing the building blocks. You can imagine the building blocks as a template of the project, as a template of the infrastructure. So basically, new developer will come, or you can get new task that you should create new API, right? It happens in our company almost every day, and you don't need to take care about what kind of check should I have? Should I use logging? How should I use logging? Should I have PagerDuty, as Stanley mentioned, or shouldn't I? So at the end of the day, this should be already prepared in the template you will just use. Besides that, we are auditing the current projects, because currently we have hundreds of projects in our code base, and we would like to keep the same standard across all the services. Currently, my team consists of 3 sub-teams. The first one is data squad. Their responsibility is to take everything from basically shared network disk through Redis in-memory caches and through the SQL databases to Scylla or Cassandra cluster. Then we do have infrastructure squad. Infrastructure squad is kind of responsible for infrastructure. It means you don't need to take care about what hardware you are going to use, in which data center you should do that. They will provide the building blocks. You will just use it, and you will create it. And it will also create domain for you. It will create monitoring for you. It will create staging for you in the end. And software, as I mentioned, we are providing the building blocks. We are providing the templates for new projects, and we are also doing the auditing. I'm also a fresh, happy father. I have a daughter for 2 months, so I'm kind of used to new life. And also I love whiskey, but tonight I would be happy also for vodka because I'm so tired now. Okay, this is wrong button. Yes. So KiwiCom in couple of numbers. This is kind of boring part because already Stanley and Tin mentioned that, but currently we are doing around 10,000 bookings per day. Every booking could have multiple flights, so we can imagine those amount of data which are actually crossing our systems every day. We have around 300 microservices, which are behind that entire Kiwi.com nice front-end web page. We are now in 10 plus locations. It's also on the poster, so we have offices in Barcelona, in Brno, in Prague, and Czech Republic, also Bratislava, Split, and so on. We have mainly I would say around 80% of the microservices are written in Python. We have few written in JavaScript, Go, or C++. And also we have like a lot of databases in place. So we need to store the data, we need to store the flights, we need to store basically information about the bookings. So we have around 80 Postgreses. There is also a lot of read replicas because we need to kind of make sure that, that reading isn't like causing the much outage or much load to our main databases when we are writing to. Also, we have huge Stila cluster. It means like we have 20 plus nodes and around 100 terabytes of data there, which is every I think 48 hours. So since we have a lot of microservices, we need to communicate between each other somehow. We are using API. API is basically everywhere, right? So in order to have like this kind of API and this kind of communication, we need to be sure that what service should be dependent on what service. Like, how can I rely on this service? Is it okay to rely on 25 services or just these two, or like what's going on there? And to like in order to do that, we need to always have like up-to-date requirements, up-to-date databases to use the newly features because we don't want to have like security breaches there and stuff like that. So my question is, do you upgrade regularly? Like Python requirements. Who is doing that? Nice. Like databases. Okay. And what about like your system, your operating system on your laptop? Okay, yeah, but you know you should do that. That's like it's intentionalized, needed. And why do we need the upgrade? Like usually it's cool to have latest technology, right? Everyone is like a little bit geek inside and allowed to play around new features, which could bring you a new version. Especially in Postgres 10 plus cases, there were like 4 or 5 major improvements. It was improved query parallelism. So basically, you did upgrade and your query were fast. You haven't touched anything because on the machine, the query were running on multiple cores instead of one. So it's for free. It's great, isn't it? Then some logical replication. It means that you are able to mirroring some data, doing some like transaction on that and putting into another database. Huge thing for us was also declarative table partitioning. So you don't need to do the ugly hacking anymore with the triggers on every table, and if they did this, put it into this table and stuff like that. Also, there are always like lot of security enhancements. So yeah, so we need to upgrade, but I will tell you a kind of story what happened to us. I think it was like 2 years ago, and we were like, okay, this new database could bring us a lot of more powerful features. I think it was like from Postgres 8 to Postgres 9 something. And we tried that and it was working fine before on some backup. And then we kind of called all the partners that we are going to have scheduled maintenance, don't worry, we are fine, but we will a little bit offline. So we came to the company, sit there and waited for the scheduled time. And then we just go to the AWS console and just click upgrade. And we were waiting 1 minute. Somebody left for coffee, 5 minutes, maybe another cigarette or maybe another coffee, like 20 minutes. Well, after 45 minutes, it became to be like a little bit suspicious, like what's going on, right? Because the machine was still upgrading and we kind of supposed it will be done in 10 minutes, but it wasn't. And on the AWS, Amazon Web Services, you have basically zero visibility what's going on. So, like, we weren't able to actually do anything, right? We need to just wait and actually pray like what's going on. So this is how it looks in our office actually, and. Lucky, we had some kind of luck because we kind of managed to get on call some AWS support, technical support, which actually checked the logs and told us that, well, because of this extension, in order with this permissions problem, we are not able to do that. Well, so please, could you at least like start our old database, then we can run the business. So we kind of managed that, but it's definitely not good. To sum this up, like how we did it before, we did AWS console click. And there was a lot of manual steps, like we need to stop the traffic to the database. We need to stop all the services in an application because we didn't want to like put random errors to our clients, to our customers. We need to do backup, we need to upgrade, and then we need to kind of pray that the database will actually start, right? The problem is on AWS console that you have zero or like low visibility in the logs, and there is a lot of manual tasks around that you need to prepare, like all of the customer, all of the partner. You need to synchronize between the teams that our service will not be working. So if your service depends on our service, you will be also like in the trouble, and we need to announce that ahead. And we kind of didn't want to do that. Anyway, what was the props of the RDS? The backups and point-in-time recovery are great. You don't need to take care of anything. You just like spin up new instance there, and you will tell that, okay, I want to backup every 2 hours, and I want a retention for 1 month, and that's it. You don't need to set up the cron. You don't need to set up a special script for that. There are also replicas, which are very cool, and also the patch version, like the last one. Actually, RDS is able to do that for you, and you don't need to even notice that. What's not so helpful is pull logs. It can do replicas between the major versions, and I will get to this later as well. And you are basically blind. You don't know what to do, and you're just blindly waiting for the database. Will it start or it will won't? So it means like a lot of lost opportunity, a lot of lost revenue. So like there must be a better way to do that, right? So let's define what do we need. We would like to upgrade databases. We would like to use the latest technologies. We would love to play around the new cool features there. But also from business point of view, we need to have like zero downtime. That's perfect state. But nearly zero is also, I would say, acceptable. So first, which came across our minds was like, we are not probably the first company that needs to solve this, right? So what other companies are doing? The response was that there are some managed solutions. So they will install database for you, and they will take care of upgrades. There is some SLAs for the availability of the database, but it's not so as good as we wanted to have. I've been in touch with, for example, Second Quadrant, which is like leader in Postgres databases, and they kind of told me that, sorry, we are not able to do RDS migration. We can like spin up like new cluster for you. And then it will be automatically. Well, I said, okay, but in case I would like pay you for this, how you will move us from RDS there? Like, still the same problem. So we kind of decided that we need to be better, and we have some battle plan for this. By the way, this is my first animation, so I hope you will like it. The battle plan was that we have some source DB. We were basically drawing this to the whiteboard and kind of thinking about how should be the principle of upgrading database without downtime. Yeah. So we have the source DB. The source DB has some host, so you can easily connect there. But what if we will put some domain name, like DNS alias CNAME, pointing to that database, okay? So we can do this. We can tell all the clients of the database to use that DNS. So everyone, there is no like impact, there is no outage. It will just use one step before it will need to resolve the CNAME. Then we can somehow, we don't know yet how, set up the mirroring. So we will spin off new instance with the target version, with the newest version of Postgres, and we will set up the mirroring between them. So each data which are written or updated on the source will be also updated or written to the destination. Then at some point, we can do actually this. So we can change the pointing of the DNS to the destination DB, and everyone is now using destination DB. So we are fine. We can just basically remove the old one and mirroring, and we have upgraded that. But how do we get there? We need new instance. That's easy, right? You can easily spin off new instance in AWS, and that's fine. DNS, there's also no problem with that. Maybe keep in mind that we are going to change the DNS. It means that all of the application needs to, in like low period of time, to start using new one. So it means let's put minimal TTL, time to live, on that DNS record. Then we need somehow do mirroring. We don't know how, and that's funny part. And also, we need to be sure that data are same on the instances, that there is no discrepancy in the mirroring. So how we approach this? As I said, we need to do the mirroring, and we need to do check the integrity of the data. And then Bucardo comes. So we tried to Google few tools around the Postgres, and Bucardo was really the winner for us, because this mirroring tool is very easy to use. It's an open source project, and we set up that like during one Friday afternoon to try that. And how it is running. It uses basically another instance, another like computer, let's say, another server. You will install it, basically you will run it. You need to do some initial run. It means like you will have empty instance, and you need to fill it up with all the historical data. And then you need to proper mirroring the sequences and the tables. So the preparation, how to use Bucardo, there are a few comments. I'm not sure if it's readable from the end. Anyway, you will just basically say that this is the source DB connection string, and this is the target DB connection string. And then you will just tell Bucardo, okay, I want to mirror all the tables, because you can mirror just like few of them, and you can do like one mirroring to be into like 5 databases and different tables and stuff like that. Anyway, this is simple. I want to mirror all the tables. I want to mirror all the sequences. And I'm telling Bucardo to start. And Bucardo start doing the mirroring for us. How it's working under the hood? Bucardo creates triggers for all the tables you have in your schema. It means like each table will have trigger on update and on insert. And by doing insert or by doing update, it will put the new record into some temporary table, like Bucardo one. Let's imagine it as a queue, and then like binary from the server, the Bucardo one will take it and actually push that difference or that new record into the destination DB. This is how it's working under the hood. Another problem, as I've been referring to, is integrity of the data. For our purposes, was very like crucial to have good integrity, like perfect integrity, and it was more important than have outage for, I don't know, 30 seconds or something like that. So we decided to create like very easy Python script which will check all the sequences, all the tables, all the data. So basically, how the script is working, it will just select all the source tables. It will select all the sequences and check their values, obviously. And for each table, it will get ideally all of the data and compare them. But we do not want to have outage for like 1 hour or 2 hours to be selecting and pulling all the data from both databases and comparing them. That's not so smart. So we are thinking how we can actually improve this. So as we are using in our application, this is one of the standard that every table has 2 columns, which is created it and which is updated it. This basics triggers will allow you to have this kind of logic that you don't need to take care about like when the record was saved there or when the record was updated. We are using that on all our tables, and it's like profit. So we decided to use actually these columns in the integrity check. So basically, what we did is we selected like last I don't know 10,000 records based on updated at, and we knew that all of the other data are basically the same. So how the script is written? There is threads everywhere. Basically, for each table, I spin off some thread, and they was just doing one job, and that was comparing the source data and the destination data. Also, we need to be really fast, so we used pooling to both databases. We have like, I would say, like 20 connection into one pool and 20 connection into second pool, like the source and destination pool. And we kind of had to optimize queries to run as fast as possible. For example, this one for taking all the sequences last values, because if I would run it in the for, so it would take, I don't know, like 2 minutes, right? But if you run it in one SQL query, which is like incredibly long, but it's just first two, right? It will do that in half a second or something like that. Yeah, and what about the feature? Like we would love to. No. We would love to have some automated script which do upgrade for you, or like semi-automated. It means that you want to do upgrade from Postgres 10 to Postgres 11, and it will do all of this logic as I explained it, and we had to do that manually. It will do that automatically. So we are working on that, and we are going to provide it like an open source to everyone actually can use it and easily upgrade its databases. So for the takeovers, use logical replication if you can. If you are on Postgres 10 plus, logical replication is really good. Try to check it. If you don't have like Postgres 10 yet, use Bucardo. It's good. It can do the job. It can do the mirror. It can do the replication. It's fine. And also, from our point of view, is like it's always better to be safe than sorry. So the integrity check was kind of mandatory part of that, and you should also like think by doing the upgrades like what's the more important? Is it an outage or is it the integrity of the data? Yeah. And thank you for your attention. And do you have any question?
Thanks you so much. Questions? Alexander, you don't have any questions? Okay. Not this time. People get tired a bit. Oh, okay.
Hello. Thank you for the talk. What was the dataset size of the database you upgraded?
Yeah, in this case, okay, the question was, I'm not sure if everyone heard that, what was the data size of the database? I think it was around 200 gigabytes in this case, yeah. But it doesn't basically matter, because if you do the initial run, which basically mirror all the historical data, then it doesn't matter. It will run like maybe a day, maybe 2 days. You basically do not need to care, right? But after that, the actions which we are doing like during the upgrade are more important. And in that case, it doesn't, like you can have like 10 terabytes and 10 terabytes, and delta will be like always definitely smaller. So you can mirror it very, very fast and very easily.
Okay, thank you. Anyone else? I think that's it. So thank you so much.
Thank you, guys.